All right, in this video, you're going to spend a little bit of time trying to learn what you can do generally to solve a system of equations with elimination. It is really important that you have already looked at the systems of equations with simple elimination before you watch this video, because this video will make a lot more sense if you've already done the simple elimination thing. So just a word of fair warning there. The essential question that we are dealing with here is how can I prepare a system so that I can solve it by adding the equations together? And so if you need to take a moment to write all that stuff down, just pause the video and then catch up with me. When is a system ready to add is our first important question. So if you're remembering back to the systems of equations with simple elimination, there's something really beautiful that happens when the following thing is true. So I'm going to start with an example, and then I'll describe the example. So let's say I have 3x plus y equals, let's say, 14. And then I have negative 3x plus y equals 2. Something really beautiful happens here when I add these two equations together. If I were just to add them, I would get 0x plus 2y equals 16. And so what happened was that the x term fell out because positive 3 and negative 3 become 0. And so that's the first thing I'm going to describe. I'm going to circle this and make a little arrow here. A system is ready to add when the coefficients for x or y are opposites. So an example, 3 and negative 3 are opposites. 4 and negative 4 are opposites. Negative 6 and positive 6 are opposites because when you add them all together, you get 0. And that's going to eliminate one of the variables. That's why this is called the elimination method. Sometimes it's called the linear combinations method. So you know a system is ready to add when you have one of the variables positive, and then the other variable is negative, and they're the same number except for that negative. So let's go ahead and look at an example where it's not already prepared, and we'll go ahead and use this example and look all the way through it to see how this whole process works. So how can I make a system ready to add? We're going to use this system that you see over to the left. So it's negative 4x minus 4y equals negative 48. And then I have 3x minus 5y equals 4. And so I'm going to do my check here. I'm going to go ahead and look. 3 is not the opposite of negative 4, so if I add those together, I'm not going to get 0x right now. So that's the first thing to note. Then I'll check the y's. Negative 4 and negative 5 are not opposites either. And so I need to do something to this system of equations in order to make it ready to solve. And so here's what I'm going to do. You've known for a long time that it's okay to multiply both sides of an equation by the same thing. And so I'm going to do that to both of these equations. It would sure be nice, I'm going to just think about this as a goal for a moment. It would sure be nice if I had, for the top equation, I had negative 12x's, and in the bottom of the equation, I had positive 12x's, because negative 12x plus positive 12x is 0x, and one of the variables would cancel. So now that I've thought about that goal, I'm going to do some stuff to try to make that happen. This is the notation I like to use. So I'm going to multiply the top equation by, we'll forget this notation just for a second. We're going to multiply the top of the equation on both sides by positive 3. And if I do something to one side of an equation, I have to do something to the other. And then we'll multiply the bottom equation by 4. You might think, well, how did I know, or why did I think of 3 and 4? The question is, how can I take negative 4 and make it into negative 12? That's my goal. And so in order to do that, I need to take negative 3, I need to take 3 times negative 4 to make it negative 12. The same thing is true down here. If I want to make 3x's into positive 12x's, I have to multiply them by 4. And so I need to carry out this whole thing. Because I'm multiplying both sides of the equation, everything in the equation gets multiplied by the same thing. So 3 times negative 4y is negative 12y. And 3 times negative 48 is going to be negative 120 minus 24 is negative 144. On the bottom, it's 4 times 3x gives me 12x. 4 times negative 5y gives you negative 20y. And 4 times 4 gives you positive 16. Okay, so now I can finish my addition here. The beautiful thing that I wanted to happen happens. The 0x occurs. I'm going to have negative 12x minus 20y is negative 32y equals, and then negative 144 plus 16 is going to be negative 138, negative 128. And so now I have negative 32y equals negative 128. And so in order to solve that, I'm going to take a few more steps. I'll divide both sides by negative 32. And so that is going to be y equals, looks like positive 4. Once I have the y value, if you remember from your systems of equations with simple elimination, you have to plug that back in now to one of the original equations. So I'm going to use the second equation. It doesn't matter which. So y becomes positive 4. I multiply, add 20 to try to get x by itself. So 3x equals 24. Divide by 3 so that x is equal to 8. And so now I have my solution, 8 comma 4. And so how can I make a system ready to add? Let's summarize what you need to do. I'm going to kind of jump page here. Well, maybe we have enough room. I'll jump page. So in order to make a system ready to prepare, multiply one or both of the equations in the system so that one of the variables will cancel. And so the example that we looked at, none of the variables cancel immediately, so I had to multiply the top equation by 3 so that it would give me negative 12x, and the bottom equation by 4 so it would give me positive 12x. And then when I did that, I had to remember that everything in both equations gets multiplied. And from there, I got this beautiful thing to occur where positive 12x plus 12x gives me 0x, so it left me with an equation with just one variable. So for these systems of equations with elimination, it's really one or two additional steps from the systems of equations with simple elimination. So if you need additional help, please make sure that you ask for it. Before you move on, though, you should take a moment to write the summary. And your summary should definitely be an answer to the essential question, which was, how can I prepare a system so I can solve it by adding the equations together? And so try to think about the important things we've talked about in these notes, and then make sure you write that summary, and I'm sure that you'll do okay on the exercises. These problems sometimes take a few minutes to solve, so please be patient with them and take your time on them. If you miss one or two of them, it's okay. Just make sure that you're persistent. That is the most valuable thing you can do. Again, ask for help if you need it.